Hello everyone, this is Dr. Surya. So today we are going to see about the basics of trickling filter and a problem on trickling filter. So what is this trickling filter process? So it is going to be a biological system to remove your dissolved organics and finely divided organic solids using microorganisms. So using the microorganisms, we are going to remove of all the dissolved organics which is attached to the media. And for this particular thing, it is working under your aerobic conditions. So this aerobic microbes, this will oxidize the organic matter into the simpler form. Okay, so it is this trickling filter is a type of the wastewater treatment system, and because it is a filter, it consists of a different media like rocks, gravel, slag, ceramic, plastic media. So through all these media, our sewage or other wastewater will be flowing in a downward direction. So when anything is flowing in a downward direction, so the particles which is bigger than that particular pore size, it will stagnate on that particular layer itself. So likewise, it will cause a layer of a microbial slime, that is nothing but your biofilm. So certain biofilms will be growing in that actually, and this biofilms will cover the entire media. Okay, and what will happen is that because it is a biofilm is growing, biofilm is there or particles is there, means automatically bacteria will be there, because this is going to be a waste material. So this waste material and this microbes, it needs some certain food also. So this will eat all the organic materials that is present in the waste, and for its survival it uses its air. So this is going to be an work under your aerobic condition. Okay, and it since because it is a filter, it consists of the coarser filter media also. In that, what we will be doing is that either we will be sprinkling or we will be trickling down the wastewater, either by means of spray nozzles or by means of your rotary distributor. So this percolating sewage, and this finally it will be collected at the bottom of the tank. So what has happened is that large scale growth of the aerobic bacteria will be there, and sufficient oxygen will be provided by means of your ventilation facilities. So if the bacteria is growing, means what will happen, it will eat all the oxidize whatever it is there, it will oxidize all the organic solids, organic matter into a simpler form. Okay, then later the final effluent, it will be released from the effluent pipe, it will be treated with the disinfectant. So in simple I can say is that first I will be feeding my primary influent. Primary influent is your wastewater, okay, through some feed pipe. Then after that, by means of that, it is going by means of your influent distributor. Okay, so by means of an influent distributor, it will be glowing it. Then it will pass through your filter media. So in this filter media only, you will be having all your microbes. Okay, so after this, it will be oxidized by means of the oxidation process is taking place. So oxidation by means of the microbes. Oxidation is carried out by means of the microbes. Then it will be taken to your clarifier. So clarifier is nothing but your sedimentation tank or settling tank. And here this clarifier, this will out of the effluent, it will take away all your waste sludge. So waste sludge can be removed. Okay, then this waste sludge, again it can be recycled. So recycled to your trickling filter, and if needed you can treat it with some disinfectants like chlorine, and you can reuse it. So this is how your trickling filter is working. Okay, so now we'll come to the type of trickling filter. So there are two types of trickling filter. One is going to be your conventional trickling filter, or your low rate trickling filter, or your standard rate trickling filter. Okay, next will be your high rate trickling filter. So this high rate trickling filter you will be having with certain modern advancement will be there. So when you come back to your design of the trickling filter, two types of loading has to be taken care of. So one loading is going to be your hydraulic loading. Okay, So hydraulic loading means the quantity of the sewage that is going to be supplied for one per unit of surface area of the filter. So which is nothing but your sewage. So how much quantity we are going to apply or supply for one unit area, unit surface area. Surface area of the filter per day. This is going to be called as your hydraulic loading, and this will be expressed in million liters. You have to be careful. So this how much amount of sewage is going to be supplied for one unit area of the filter, and this is going to be expressed in million liters per hectare per day. Okay, so per hectare denotes your surface area and for per day. So million liters per hectare per day. Second type of loading is going to be your organic loading. So this organic loading is nothing but your mass of BOD. So how much mass of BOD we are going to supply per unit volume of the filtering media. Okay, volume of the filtering media per day. So this is going to be called as your organic loading. Okay, this usually they will be expressed in terms of your kg of BOD per hectare meter of the filter media per day. So it is kg of BOD per hectare meter of the filter media per day. So this is going to be the some of the basics of your trickling filter. Again, this is going to be called as your trickling biofilter or biological filter, or it can be called as your percolating filters or sprinkling filter. Okay, now we'll proceed to the problem. The problem given is that we have to determine the size of the high rate trickling filter for the given data. So they have given the flow as 4.5 MLD, recirculation ratio is 1.4. So recirculation ratio is nothing but how much amount of wastewater is flowing through this pre-treatment component, that is through this trickling filter, divided by the amount of wastewater that is sent to the final treatment or for final disposal. So how much of wastewater that is coming inside the trickling filter and how much of wastewater that is going out to the dispersal. So that is going to be the recirculation ratio. Then they have given the BOD of raw sewage, and they have told that BOD removed in primary clarifier is 25%. So initially the raw sewage, so initial sewage is going to be 250 milligram. So first it is passing through your settling tank. So in passing through your settling tank, 25% of this 250 milligram per liter BOD has been removed, and final desired BOD will be 50 milligram. So if it is 250, 25% is removed in primary settling tank, and after passing through the trickling filter, we should get the final BOD as 50 milligram per liter. Now they have told that you have to calculate the size of your standard rate trickling filter also. Okay, so we are going to design first our high rate trickling filter, and then we have to design our low rate trickling filter. Okay, now we'll move on to the problem. So which is first, what is the amount of BOD present? So total BOD present in the raw sewage. Present in raw sewage. So if you take initially the BOD is 250 milligram per liter, right? And your wastewater is 4.5 million liters per day. Okay. Now if you see the unit, this is in milligram and this is in million liters. So if you see here 250 milligram per liter, which means for 1 liter you are having 250 milligram of your water. Okay, then for 4.5 million liters, so which is equal to 4.5 into 10 power 6 liters. So which is 250 into 4.5 into 10 power 6, which is going to be 1125 into 10 power 6 milligram. So this is what you will be getting. But I have to, this all your loading should be in kilogram. So 1 milligram will be equal to 10 power minus 6 kilogram. So you are going to convert this, which is 1125 into 10 power 6 milligram is equal to how much kilogram? So 1125 into 10 power 6 into 10 power minus 6, which is going to be 1125 kilogram. So this is going to be the total BOD that is present in your raw sewage. Okay. Now the BOD that is going to be removed in primary clarifier. So how much BOD has been removed? 25% is removed. Okay, so per day how much BOD is going to enter? That we have to calculate. So BOD entering per day is equal to, in trickling filter. Okay, since because 25% is removed, which is 100 minus 25. So how much will be entering inside the trickling filter? 75% will be entering. So how much BOD we are having? 1125 kilogram. So BOD entering will be entering in trickling filter per day will be equal to 0.75 into 1125 kilogram. Okay, so which is 843.75 kilogram. So this is going to be the amount of BOD that is entering per day in your trickling filter. Okay, so you have to be very careful in this. Next, what is the final BOD or final effluent BOD that is given in the problem? That is desired BOD is going to be 50 milligram per liter. Okay, the same way only we are going to calculate. Now BOD allowed to go in the effluent. So allowed to go in effluent. So how much is allowed? 50 milligram. But initially how much amount of water we are passing? 4.5 million liters is passing. So I have told you the conversion already. So it will become 225 kilogram. So how much amount of BOD has been removed now? So initially how much BOD is entering minus how much BOD is going as an effluent. Okay, so initially how much is entering? If you see here, 843.75 kilogram is entering, and we are final is going to be 225. So how much amount of BOD is removed? Which is 843.75 minus 225, which is equal to 618.75 kg of BOD is removed in our trickling filter. Now we are going to determine the efficiency of the filter. Okay, so how much BOD is going to be removed? So efficiency eta is equal to BOD removed divided by total BOD entering. Okay, so BOD removed is nothing but your into 100. You have to write it in 100%. So 618.75. This is the BOD removed. Total BOD entering is 843.75 into 100, which is equal to 73.3% of your is going to be your efficiency of the trickling filter. Okay, now we have to determine the size of the filter. Generally the size of the trickling filter means trickling filter will be in circular in nature. So we have to determine the trickling filter by means of your diameter. Okay, so how to get the diameter value? For that you are using a formula. So efficiency is equal to 100 divided by 1 plus 0.0044 root of W by Vf. So this is the formula we are going to use. So efficiency formula is given. So we have already determined the efficiency. If you see here, W is going to be the total BOD applied, V is going to be the volume of filter, and F is going to be the recirculation factor. But if you see in the problem, so just go back to the problem. If you see in the problem, they have given the value of recirculation ratio, not the value of your recirculation factor. So we have to determine our recirculation factor using our recirculation ratio. So for that we are having a one more formula, which is F is equal to 1 plus R by I divided by 1 plus 0.1 of R by I the whole square, where this R by I is going to be your recirculation ratio. So you can apply here. It is given in the problem of recirculation ratio is 1.4 divided by 1 plus 0.1 into 1.4 the whole square. Okay, so I will be getting my F value as 1.85. Now I have to get the value of my volume of filter using the efficiency formula, that is efficiency is equal to 100 plus 1 plus 0.0044 root of W by Vf. Okay, so here what I am going to do is that efficiency is 73.3, so you don't want to convert it into 0.773, just keep it as such, since because we are putting 100 and all, let it be as such. So 73.3 divided by 100, that's why that 100 is here. So put as such 100 divided by 1 plus 0.0044 root of W is your BOD, that is entering, that is 843.75 divided by V into your recirculation factor, what you have got is here 1.85. So now we are going to do all this conversion, that is 73.3 is equal to 100 divided by 1 plus 0.0044. I am taking this, I am dividing 843.75 by 1.85. Okay, and I am taking the root also. So what I will be getting is that 0.094, sorry, I will be getting 21.35 divided by root V, because you are having one root. Usually the common mistake what we make is that we will forget the root and all. Okay, now I will be calculating this. So again this is 73.3, which is 100 divided by 1 plus, just multiplying, I will be getting 0.094 divided by root V. Okay, next 73.3 100 multiply this root V, I will be getting root V plus 0.094. Okay, since because it is going to be in the denominator, I am bringing that root V here, which is going to be 100 into root V. Now multiply the 73.3 with this particular term, so it becomes 73.3 root V plus 6.88 is equal to 100 into root V. Okay, so bring that 73.3 root V to the other side and just subtract it. I will be getting 26.7 root V is equal to 6.88. So root V is equal to 0.257, square on both the sides to get your V value. So my volume of filter will be equal to 0.066 hectare meter. So usually your volume will be in of hectare meter. So I will be getting 0.066 hectare meter. Okay, now 1 hectare meter is equal to, or 1 hectare is equal to 10 power 4 meter square. Okay, so in that case my volume will be equal to, so I am having 0.066 hectare meter, so it becomes 0.066 into 10 power 4 meter square meter, so which is equal to 66, I'll write one more decimal also, this is going to be 665, so 665.4 meter cube. So this is going to be the volume of the filter. Now what I am going to do is that I am going to assume the depth of filter as 1.5 meter. 1.5 meter as depth. Okay, so if that is the case, okay, what will be your volume? Volume is nothing but your area into depth. So area will be equal to volume by depth. So volume is 665.4 and depth is going to be your 1.5. So area of the filter is 413.6 meter square. So if area is known, easily we can calculate our diameter, because the formula for area is pi by 4 d square. So area we have calculated as pi by 4 d square, sorry, pi by 4 d squared is equal to 413.6. So my D will be equal to 23.8 meter. So the size or dia of high rate trickling filter is 23.8 meter. Now with this the problem is not over. So we are having one more things, which is that we have to get the size of your standard rate trickling filter also. So in order to obtain your standard rate trickling filter, okay, so for standard rate trickling filter, you have to assume your circulation factor, that is F value as 1. If just assume your F value as 1, then it is going to be your standard rate trickling filter. So use the same efficiency formula, which is efficiency is equal to 100 by 1 plus 0.0044 root of W by Vf. So use the same formula. So for your standard rate trickling filter, again the efficiency is 73.3. 100 plus 0.0044 divided by root of 843.75 divided by V into F value is 1. So when you simplify this, you will be getting your volume of filter as 0.1233 hectare meter. So which is equal to 1233 meters cube. Okay, now after doing this, you have to do the same thing. Assume depth is 1.5 meter. Okay, so you will be getting your area value. Area is your volume by depth. So what we have done for the previous step, the same thing we are going to do it. That is for your high rate trickling filter. What are the things we have done? The same thing we are doing. So I am getting the area as 822 meters square. Then pi by 4 d squared is equal to 822 meters square. So D will be equal to 32.4 meter. So the size or dia of low rate trickling filter is equal to 32.4 meter. So this is the answer. Okay, I hope you have understood the problem and the concept of the trickling filter. So for the other subject, the playlist has been given in the description box. Do watch it. Happy learning and thank you.